Today we'll be going over this Leetcode question on graphs. The main mental hurdle to get over is to realize that if each of these edges were actually bidirectional, then what does a problem really reduce down to? We would just be looking for edges that are pointing a specific way, and that is the direction that is away from 0, because these are the ones that we need to flip, right? So if we were to build a graph with bidirectional edges initially, all we have to do is create a list of edges for each node, and then we can BFS or DFS starting from node 0 outwards. So how do we know which edges need to be flipped? Let's look at the example that they gave us. So if we start from 0, we can access 1 and 4. But which of these needs to be flipped? It would be the edge from 0 to 1, right? Because we actually would want this to be going from 1 to 0. So, if during our graph traversal, the pair current node, next node is in our set of original edges, then we'll increment our counter by 1. And this is what the solution looks like, and I'll walk through it line by line. So obviously we have to have something keeping track of the number of edges to flip, and then this is just creating a set of our original edges, so we get to check whether the pair current node, next node is in the original input in O of 1 time. And then we construct our traditional list of edges here. Note that we make this a bidirectional edge by appending it to both I and j, or the first and second node that are given to us for each pair. And then we do a DFS here. So we pop off the first node, which is going to be 0 initially. For each of the nodes that are connected to it, we make sure that we don't loop by using this visited set here. We append it to the stack, and this is the key part that I was talking about, where we check if node, next node is in the original edge, and if it is, we would increment toFlip by 1. So for example, say we are going to explore from 0 to 1. This is provided in the original edges, and we know that this direction is incorrect, which is why we increment toFlip to 1. So if I run the code, we see that this is accepted, and the runtime is going to be O of n, because each of these operations is O of n, and then we do a DFS and we touch each node exactly once, so that's also O of n. And then the space complexity, this takes O of n space, this takes O of n space, and the stack will also be O of n space. So let me know if you have any comments or questions in the comment section below, and see you next time.